Okay, I'm going to try this again. On the last video attempt, the video corrupted on me, so we're going to try this one more time. I know y'all are really excited about hearing me on video today. We're going to attempt to kind of go through some stuff about parametrics. I'm going to start off actually on note card 32, talking about the derivative, and we're going to skip note card 31. So we'll kind of cover those topics as we go. I'm going to look at number 1 in note card 32. The first problem is that we have an x of t of t cubed minus 3t squared. So x, x of t is is t cubed minus 3t squared, and y of t is going to be equal to 2t cubed minus 3t squared minus 12t. What I really want to make sure we are aware is that this is saying that the position of this particle with respect to time in the horizontal direction is defined by this function, and its position in the vertical direction is defined by that function. So basically kind of what we're saying is that this is not necessarily a function of x or a function of y. We could actually cover the same ground twice. It might not pass the vertical line test, as it were. And we are saying that we are turning this into just merely two different functions of time to be able to determine its position. And this first problem is actually asking us, when is this thing at rest? And if we're trying to think of something, and we're trying to think of when is it at rest, we mean basically when is the derivative, or when is the speed maybe, or velocity of this particle 0? Is when it's going to be at rest, when the velocity is 0. And the velocity is only going to be at 0 if both the horizontal movement and the vertical movement are 0 at the same time. Very important, at the same time. Not every time x prime is 0, not every time y prime is 0, only when they are both 0 at the same time will our particle actually be at rest. So let's see if we can figure that out. Let's see, x prime of t is going to be 3t squared minus 6t. So we're going to set this thing equal to 0. Remember, always on a different line on the AP Cal exam. T minus 2 is 0, which gives us 2 times t is 0 and t is 2. So those are two possible times when we might actually be at rest. Our y prime of t is going to equal 6t squared minus 6t minus, was it minus or plus? I think it was minus 12. So we're going to figure out when this is equal to 0. So t squared minus t minus 2 equal to 0, or 6 is equal to t minus 2 and t plus 1, which can give me values of 2 and negative 1. The only one that matches in both for y prime and x prime is 2, so the only time this thing is actually at rest, this particle is at rest, it was when time is equal to 2. Okay? Everybody cool with that, I hope. Okay, so I was going to spend a little bit of time with problem number 2, but problem number 2 is a calculator problem, and since it's going to be really hard for me to display the calculator usage on this video today, I'm going to instead go on to note card 33 in just a second. But I do want to bring up how we find the slope of a parametric equation, and that is we need to take y prime, the derivative of the y stuff, and divide it by x prime, the derivative of the x stuff. And if you think about this, if you kind of think about taking this bottom fraction down here and turning it, instead of dividing by the fraction, as multiplying by the reciprocal, you will see that the dt's will cancel, and it will in fact leave you with dy dx, which we kind of accept as slope. So here we are, we're moving into now note card 33, talking about the second derivative, and I'm just going to go ahead and move into this problem. X of t is t squared plus 1, y of t is t cubed. So we have x of t is t squared plus 1, and y of t is t cubed. And they want us to find the second derivative, so we need to find x prime is 2t, y prime is 3t squared. So dy dx is 3t squared over 2t, or 3 halves t. To get the second derivative, we have to do something slightly different than you may be used to doing. We're kind of used to saying the second derivative is just the derivative of this. But the problem is that this is actually a derivative with respect to time, whereas this is talking about a first derivative with respect to x. And this is talking about with it x squared. So to be able to do this correctly mathematically, we need to take the derivative of this thing, which is what you would have done, and then divide it by x prime. Okay, so we'll take the derivative of this. This is the derivative of dy dx with respect to time. So the derivative of this is going to be 3 halves. And then dx dt needs to go in as well, so divided by 2t, or basically the second derivative of this is going to be 3 over 4t. Okay, this here, okay, is my answer. Alright, this is okay. Alright, I hope that's great. Okay, so we are now on the second problem on the second derivative page. Hopefully that second derivative didn't seem like a big deal. To be able to find the second derivative of this particular function, they want us to actually do it when y is 12. So first I need to figure out when y is 12. So that is going to be when 12 is equal to 3t squared, or 4 is equal to t squared, or t is equal to plus or minus 2. But good for us, time had to be positive. It was listed in the problem. I'll show it to you right here. So time is in fact greater than 0. Okay, and so now that we know that, we should be able to go ahead and start solving our problem. So let's go ahead and find our first derivative. That's going to be y prime over x prime. So dy dx is in fact 6t over 1, minus 2 over t squared. That is dy dx. But we aren't asked for dy dx. We are actually asked for the second derivative when y is 12, or basically when time is 2. Okay, if you want to kind of think about it that way, link these two things. So the second derivative is going to be equal to, remember the derivative of this, which is going to be, in this case, a quotient rule, low d high minus high d low. D low is going to be 4 over t cubed, all divided by the low squared, 1 minus 2 over t squared, all divided by the x prime, or 1 minus 2 over t squared. And basically what we need to do is evaluate this when time is 2, and hopefully what happens when you do that is that you are going to end up with an answer of 24. Okay, if you don't end up with an answer, I believe it's 24. It's either 24 or negative 24. Let me go check real fast. negative 24 is in fact what you should get your answer to be. So negative 24. So if you plug these things, time equals 2 in, and you do not get negative 24, you have made a mistake. Alright.